Okay, now start with the second case. That is the value of zeta in between 0 and 1. Or equivalently, this case also belongs to the case where capital B, that is damping coefficient, is not equal to 0. Okay. Now this is by saying zeta is between 0 to 1 is equivalent to saying this expression for this our rotation. And this case is known as underdamped case. Okay. Now try to solve this equation for this underdamped case. I am going to start with this equation once again. Theta S is equal to K omega n square S into S square plus 2 zeta omega n S plus omega n. Correct? Now we are going to break it into somewhat like K 1 upon S minus S plus 2 zeta omega n divided by S square plus 2 theta omega n S plus omega. Correct? Now try to focus on this denominator of the second one. This is what? S square plus 2 zeta omega and S plus omega n square. We want to perform the partial fraction. For this, we need to find the roots of this quadratic equation. And you know the roots of the general quadratic equation. Ax square plus bx plus c is what? Minus b plus minus
root d upon 2a.
Plus minus b.
Root under b square minus 4ac divided by 2a. Okay. And for general case, ax square plus bx plus c is equal to 0. X will be equal to minus b plus minus root under b square minus 4ac divided by 2a. Correct or wrong? Correct. Okay. So equivalently, the order is 2. So the number of roots will be 2. I am going to denote it by S1 and S2. So S1 and S2 are two roots of this particular denominator polynomial. So what will be the value of S1? I am going to say zeta omega n plus omega n root under zeta square minus 1 minus zeta omega n minus omega n root under zeta square minus 1. Right or wrong? Now you can see why I have taken 1 as a limit. Because zeta square minus 1, zeta square. Okay, this is going to be hard. Okay. And since you have taken zeta, you have taken the case of underdamped system is zeta less than 1. So I am going to write these roots as just somewhat like S1 is equal to minus zeta omega n plus j omega n root under 1 minus omega zeta, and S2 will be equal to zeta omega n minus j omega n root under 1 minus zeta. Because zeta is less than 1, so I want this term 1 minus zeta square rather than zeta square minus 1. So I have taken minus 1 common, and root of minus 1 is j. J is equal to what? Root of minus. This is a complex one. You might have read in your problems. Okay. Now I am going to take another variable. I am going to say this whole term omega n multiplied by root under 1 minus zeta square is nothing but omega t. I am going to name it. I am going to take another variable omega t, and I am going to define it like let omega t is equal to omega n root under 1 minus zeta square. Correct? So equivalently you can say once again your roots will become s1 is equal to minus zeta omega n plus j omega t, and s2 will become minus zeta omega n minus j omega. Please verify this that whether up to here we are correct or not. Means we have taken this root s1, s2, we have represented in terms of j, then we have assumed another quantity omega t, and we have represented these roots in terms of omega t. So these are the roots. Now let us try to break this. Okay. Come back to our original problem. Theta s is equal to this. Equivalently, you can say theta s will be equal to k 1 upon s minus s plus zeta omega n s plus zeta omega n square plus omega d square minus zeta omega n s plus zeta omega n square plus omega d square. We have broken this term because we know the roots. Correct? Okay. Now we can find our inverse Laplace transform of theta s. Perform it. Looking very beautiful. What you will get? Theta t will be equal to inverse Laplace of theta s, that will be equal to e multiplied by 1 minus e to the power minus zeta omega and t cos omega t minus zeta omega n divided by omega t e to the power minus zeta omega n t. This is e to the sin omega t. Try to verify at your home. Okay? Because it will be very difficult to verify. You might have forgotten your Laplace transform. But this derivation has been asked for 2 marks. That's 10 marks. Okay? That's why I am deriving. Now let us rearrange this. Equivalently, you can say this is equal to k multiplied by 1 minus. I am going to replace this omega t simply. Omega t we have already assumed, so I am going to replace this omega t. You have to write fresh equation. Okay. This omega t is equal to what? Omega t equal to omega n root under 1 minus zeta square. You need to remember this term. All these terms you need to remember. Not only for semester examination but for all competition examination. Correct? Okay. So now I am going to rearrange this equation a little bit, and then we will come to our final solution. So your theta t will be equal to a multiplied by 1 minus e to the power minus zeta omega n t divided by root under 1 minus zeta square. This I am going to say root under 1 minus zeta square of omega t plus zeta sin of omega t. Correct? Okay. So now assume this term and this term respectively like this is I am going to say it is sin phi and this is I am going to say cos. Why I am assuming like this? Because I want to solve this, means sin phi cos something theta and cos phi sin theta, your formula from your trigonometry. So what you will get with this assumption, you will get tan phi will be equal to root under 1 minus theta square divided by 2. This you need to remember. For the time response, most of the things are like Ratta Maru Jindabad. Okay? If you remember, you will be able to answer, otherwise you will not be able to solve. Okay. With this assumption, what you will get? You will get theta t will be equal to e multiplied by 1 minus e to the power minus zeta omega and t root under 1 minus zeta sin phi cos omega t plus cos phi sin omega t. And now you know this part. Correct? So finally you will get theta t will be equal to k multiplied by 1 minus e to the power minus zeta omega and t divided by root under 1 minus zeta square sin omega t plus phi. Correct? This is your final response to second order underdamped system with a unit step excitation. And this particular formula you also need to remember. The more you will remember, the more you will score in time response part. Even in competition, they ask some such type of questions which are directly based on the formula. Okay, so with this particular expression, we will end this class where phi is equal to what? Phi is equal to tan inverse root under 1 minus zeta square upon g. With this particular expression, I am going to end this class and we will try to plot this complex equation in the next.